Good morning children, this is Aisha, and today in our chemistry module, let us learn about the effect of pressure on states of matter. As you all know children, matter tends to change its form from one form to another, that is, from one physical state to another. From solids to liquids, or from liquids to gases, or from solids to gases directly. So this phenomenon of the change of matter from one state to another is called as interconversion of states of matter. So matter can change from one state to another by either changing the temperature or by changing the pressure. In my last video, I dealt with the effect of temperature on the physical states of matter, and today let us learn about the effect of pressure on states of matter. So you can see over here that the physical state of matter can be changed either by increasing the pressure or by decreasing the pressure. First, let us consider when pressure is increased, what happens to a state of matter. So when a high pressure is applied to a gas, you can see over here a container and there's a piston to compress this gas. So when a high pressure is applied to the gas, it gets compressed to a small volume. Can you see the difference in the volume? It gets compressed to a small volume, and the molecules in the gas are forced to come closer. So in a gas, as you know, that the molecules are very far from each other, but when the pressure is increased, what happens? As the volume is lowered or decreased, then the molecules are forced to come closer. So, but they will be vigorously moving away from each other as there is higher kinetic energy. So, what you need to do to lower down the kinetic energy? You have to lower down the temperature. So when the temperature is lowered, the kinetic energy of the gas molecules also is lowered, and then there will be a change of states of matter from gas to liquid. So we can say that gases can be liquefied or gases can be turned into liquids by compression. Pressure, increasing the pressure can also be called as compression, and by cooling. So the temperature, if it is lowered, it's called as cooling. So we can say that gases can be liquefied, turned into liquids by compression and cooling. That is by applying pressure and lowering the temperatures. Ammonia gas can be liquefied in the similar manner. Even the petroleum gas is liquefied and is packed into cylinders as liquefied petroleum gas. Now let us consider the other situation, decreasing the pressure and increasing the temperature. So what happens when you decrease the pressure and increase the temperature? Let us consider one example of solid carbon dioxide. So solid carbon dioxide is stored under high pressure. So do you know what's the other name of it? Yes, it's dry ice. So when solid carbon dioxide is kept exposed to air, its pressure decreases to normal atmospheric pressure, and when it happens, it changes into carbon dioxide gas directly. So dry ice, when its pressure is decreased to about 1 atmospheric pressure, so it changes to carbon dioxide gas directly without the intermediate liquid phase. So what is this process called, children? Yes, it's called as sublimation. So what is sublimation? The changing of a solid directly into vapor state without the intermediary liquid state. It's called as sublimation. So let's see the definition of sublimation again. It is nothing but the changing of solid directly into vapors upon heating and the changing of vapors into solids upon cooling without changing into liquid state is called as sublimation. Here are some examples of those substances which undergo sublimation. Examples are ammonium chloride, iodine, camphor, naphthalene and anthracene. Hope it is clear to you, children. So now what happens when these solids are heated? So when these solids are heated, their particles move so quickly that they separate completely to become vapor. And these vapors, when cooled, they slow down so quickly that they become fixed to form solids. That is the reason why they don't go through the liquid state during the interconversion of matter. So that's all for today, children. Learn the concepts taught in today's module and try and answer to the questions that follow. Thank you.